Hi, this is Gilles, the radio prepper. I haven't published a video for a while now, and sometimes I have to find new ideas. Life gets in the way, and a video has to inspire me. I'm not a professional YouTuber, and if it doesn't inspire me, it certainly won't inspire you, so that defeats the purpose. So let's address the elephant in the room here. And I don't mean the fact that I need a haircut and a shave, but I'm wearing a plate carrier. Now, we're not going to talk about plate carriers. There are plenty of channels that do that, and this is not a pew-pew channel. Well, it's also a prepping channel, so I'm going to talk about an issue that comes up when you wear one of these things. And before I continue, I know some people are going to ask, so this is a Condor Vanquish. I have level 3 NIJ plates in it. They're British plates. I have side plates as well. And that's what I'm going to say about that. But again, where do you put the radio? You know, and of course you can say, well, you can attach it here with a MOLLE pouch, and you know what happens. This gets in the way. It's just not, it's not the best place here. It just doesn't quite work. I could put it on my belt, for instance, but then it's much lower. And of course, you know that height is might when it comes to radios, and that the higher the antenna is, the better results you're going to get. Also, you could have metals near your belt. Your body is in the way also. It's just not the best place to have it on your belt. I could put it maybe in the back, but then I can't see the radio, and if I have to grab it, well, it's just not that easy. In this video, I'm going to show you an antenna that you can build that can be used on a plate carrier, but also for other things. Now, probably a lot of people are going to come to this video not from the radio world, so to speak, but from, you know, other aspects of prepping. So I'm going to try to make it as simple as I can, because not everyone is interested in antenna theory, but there are some basics that I need to cover. A radio wave or radio frequency current is an alternate current, AC, and it goes up, goes down to 0, comes back up, and this is a whole cycle. So basically we have one wavelength here. Now, if you want an antenna to be efficient, it has to be ideally a half wave, because you have all the information you need here in this part. So a half wave antenna will do the trick. Most of these portable radios have generally two bands, and that's one on VHF and a band in UHF. So VHF might be something like the 2-meter band, and it's called a 2-meter band because, of course, the wavelength is 2 meters. UHF maybe would be 70 centimeters, or maybe you could have a PMR for Europe or FRS for the US, and that's in UHF. PMR, for instance, is 466 megahertz. For our example here, we are going to concentrate on the 2-meter band, VHF, so around 144 to 148 megahertz. In Europe, that's 144 to 146 megahertz. So let's say 146. So for best performance, the antenna has to be a half wave long, so that depends on the frequency. For the 2-meter band, that's 1 meter long. Now, if you look at this radio, of course, you notice that the antenna is not a half meter long. This should be a quarter wave. Quarter wave here and a quarter wave here as the body of the radio. Neither of them are actually a quarter wave. This is closer, or actually electrically a quarter wave, because there is a spring inside, or coil, which actually makes the radio see a much longer antenna. So this is actually the equivalent of about 19 inches, but the body of the radio is not the other 19 inches. So there is a deficiency here, and that's why I always add a little piece of wire connected to the negative pole of the battery, and that is actually 19 inches long. And that's your second quarter wave. Because the antenna is fed in the middle, and that's the best place to do it. So we have the current here, we bring the current to the antenna at this point. So you have the rubber ducky antenna here, and you have the body of the radio here. That should be a quarter wave, 19 inches on VHF. That should be a quarter wave as well, but it isn't. Of course, some radios are longer than others, but still, it's not quite enough to make the correct length. Note that if you have VHF and UHF on your radio, we are going to base our calculations on the lowest frequency, which is VHF. If you're using a different frequency, you can calculate the length of these branches here. In metric, you would do 143 divided by the frequency in megahertz. And in feet, 468 divided by the frequency in megahertz will give you the length in feet. So for 146 megahertz, we're actually going to use 143 divided by 146, and that's around 0.98 meters. And we're talking here about this length. So if we need to calculate the length of each quarter wave, we divide by 2, and that's going to be around maybe 49 centimeters. So half a meter, which is about 19 inches. That's why, once again, I connect a 19 inches wire to my radio here, to the negative of the battery, or you could do it to the exterior, the outside of the antenna connection here. Sometimes you have a good contact also on the screws that attach the little belt clip, but not always. You have to check that with an ohm meter. So how we are going to build our antenna here? We need a quarter wave for the radiating, well, they're both radiating elements, but we need a quarter wave for the antenna itself, the quarter wave vertical, and we need a quarter wave here to replace the body of the radio, or actually have a more efficient quarter wave here, a more efficient length for this part of the antenna. For this part, I'm going to use an antenna I already have. I don't need to reinvent the wheel. I have a longer one here, and it's actually pretty much the correct length. There is no spring inside, it's just a length of antenna, a length of wire, and I'm going to use that. So I went shopping for copper stuff. I'm looking for an end cap here for the connector, and it seems to be the right size. I've looked at 14 millimeters, 5/8, but that's a little bit too big. I thought it wouldn't fit in the MOLLE webbing. So I went for a 12 millimeter tube, and that should work. And that's going to be our quarter wave here. And of course we'll have the antenna, the already existing antenna, that's going to be here, and it's going to be fed in the middle. For the feeding point here, I'm going to use a connector. This is an SMA connector. It's a female SMA, and this is going to work great with the antenna. This is the correct connector. So the center pin here is going to be one side of my feed, and the other side is going to be attached to the copper tubing, and that's going to be my second quarter wave. I've used these connectors to make drone antennas for a video link, and you can see here it's soldered on a plate of copper. This is a helical antenna for 5.8 gigahertz, so not related to what we're doing, but I just wanted to show you here how it's actually soldered and attached. Now, if you take a Baofeng antenna, it has a female connector on the antenna, so you're going to need a male connector, not a female one. I'm using a female one because this is a Yaesu antenna, and it's just a reverse. So about 49 centimeters. You don't have to be super precise, but that's good enough. And by the way, if you don't have an already made antenna that you can use, you could take one of these meters, cut it at the right length, and use this element here as your radiating element. Of course, you would have to find a way to feed the antenna, make a connection between the two, but that's definitely something you can use. I'm going to take off the edge here because my antenna cable is going to go through that. I'm going to rough up the other end of the tube because that's where I'm going to solder the end cap with the connector. The only somewhat difficult part of this build is taking the end cap and soldering the SMA connector on top of it. So I'll have to drill a 4mm hole here exactly in the center so that this center pin here can go through and solder the two together. Well, I think it's slightly off center, but that should do it. The center pin of the connector is going to go through there, and it should of course not touch the edges of the cap. And of course I'm going to rough up the top of the cap here so that I can solder the connector on. And by the way, you absolutely have to use flux for soldering, otherwise it's just going to be a mess and it's not going to stick. If you have a super duper soldering iron, you might use that, but I prefer to use a small torch, a gas torch, and it makes things much easier. Well, it doesn't look half bad. Of course, a plumber might disagree, but pretty proud of myself. And the center pin is, well, in the center. What I'm worried about is how I'm going to solder the cable connection inside that cup, and then having to solder the cup, the end cap, on the end of the tube without melting everything off. But the tube is going to act as a heat sink, and hopefully that won't be a problem. And that's what it's going to look like. The antenna will be connected here. So we have our quarter wave here, and we have our quarter wave tube, which makes a half-wave antenna. I might want to add an O-ring here in between so that water doesn't get in. That would be a good idea. And of course, that's going to be soldered, and paint the whole thing nice olive green or something. The cable I'm going to use is an RG-316, and it has BNC connectors. This is an already made cable. I'm just going to cut it at the correct length, and on the radio I'm going to use a BNC adapter. That's an SMA to BNC adapter. The reason for that is that BNC is so much easier to put on and to remove without twisting your cable. Now this is pretty thin. It's a pretty high loss cable for VHF and especially UHF, but it's going to be fairly short, so I'm not going to worry about that. Moreover, I want the cable not to be too thick, because if the cable took up, let's say, the whole diameter of the tube here, the tube would act as part of the feed line and not a radiating element. So I prefer to have a little bit thinner cable inside. And of course the ground, the shield of the cable, will have to be connected here inside the end cap, not on the bottom. Otherwise, of course, your tube would end up being a part of the feed line once again and not radiating at all, not being the second quarter wave that is needed. This cable was damaged on one end here, so it's no loss to me to cut it. Of course, you can get the cable that's twice the length you need, cut it in half, and you can make two antennas. So you remove the insulation and you create an opening here, and you pull the center from the shield. Then you have two connections, the center, which will go on the center pin of the cap, and the shield, which will go on the cap itself, and that has to be on top of the tube, and I insist on that. So you can, for instance, you couldn't put another connector here, let's say a BNC connector, and screw it in and solder it, because the tube then would act as a part of the feed line and not radiate. So this has to go through the tube all the way up there and be soldered on the cap. Now make sure you thread in your tube on the wire before soldering here, because you're not going to be able to do it with the BNC connector on the other hand. I want to make sure I don't have a short here, so I'm going to check the outside of the connector to the center. And by the way, I got this new multimeter here, KM601. It's a great little tool, and I'm good to go. I'm going to put some solder on my center connector here and soak the shield. Now the problem that I have here is that although I can easily connect and solder the center connector on the center pin, I can't solder the shield on the side of the cap here, because of course the tube is gonna have to go in there. So I'm going to have to try to solder it on the bottom, which is going to be very much near the center pin. So that's going to be that's going to be iffy at best. All right, so let's put a bit of solder on the center. Sorry, I can't zoom any more than that. And by the way, I also checked to make sure the cable didn't have a short, because sometimes that happens. I'm going to tug on this kind of hard, make sure that it's well soldered. Although this is going to be a fairly weak connection, of course. If I was to just leave it like that and just use it, it would work for a while, but then the cable would break. So what I'm going to have to do is fill well, at least about an inch or two of the tube with epoxy after the whole thing is assembled. That way it's not going to move anymore, and you won't have any problem inside the tube, because once soldered, you're not going to get back in there. And now the shield, that's the hard part. All right, it's not sticking, and the mistake I made is that I did not scratch up the inside of the cap. Should have done that, should have used some sandpaper and scratched it up and used some flux. All right, I scratched it up a bit, and now I'm adding some flux inside. This would have been so much easier if done prior to soldering. I was able to solder the shield onto the bottom of the cap, but I had to unsolder the center. And that seems to work better, but I had to put quite a bit of heat there to make it stick. Alright, it took me some time, but a little bit of patience goes a long way. So let's check. I'm going to make a short first. Okay, so that works. Now there shouldn't be a short here, and there isn't. Let's not forget the flux here. That should fit just fine, since I didn't solder on the side. Okay, I don't want to go any further than that. I'm going to check again for shorts, and then I'm going to solder that. The difficulty here will be to solder this without melting everything else on the connection inside. So I put some solder here around. I'm going to warm that up, and whoops, I'm almost out of gas. And as soon as the copper melts, and I'm going to warm up the tube here, not the solder, but as soon as the copper melts, I'm going to remove the heat. I can see it. There should be a wick effect that should draw the solder inside the connection here. Maybe I have to lift up the tube, but I don't want to burn my fingers. It just went in, and that should do it. Hopefully my soldering inside hasn't melted, and the only way to check that, of course, is with the ohm meter. And here it is, everything checked out. It's working just fine. You can see it here mounted in the back, on the back of the plate carrier, and with the antenna on top here. The one thing that I have to add to it is to put a 3D printed tab here, something to prevent it from going lower, sliding off the moly webbing. And just one little tab here will do it. Probably I could also put one here on right on this one on the bottom. And that's about it, really. It's very convenient. It won't get in the way. And your radio has a much better antenna than the stock antenna, that's for sure. Well, it is kind of, this one is using kind of a stock antenna. Not really, though. It's longer. But you could use your stock antenna here, and with this part being the other quarter wave. So you get much better results that way. Of course, the wire is redundant now, but yeah, pretty happy about it.
Mis localement 4 sur l'extrême nord-ouest, au licence secteur nord 3 à 5 l'après-midi.
The advantage here with this system is that you can try different antennas here on top and see which one works better. Now, you're never really going to get a great SWR out of this for those who are interested, because there are so many environmental variables, the proximity of your body, other gear that you carry, or everything that's around you can affect the SWR. The way we use those radios, the SWR changes all the time. But this should give you pretty good results, and let me know how it works for you if you build one. Don't hesitate to get me a coffee, link below. Here it is with the Yaesu antenna. A little more discreet, and actually it seems to work better. Sorry, but I will not be testing this outside with the plate carrier, because this is France, not the US. And yeah, someone would probably call the cops on me. And have a good one.
You arrive with the tester for travel way, and you can proceed.